Alright folks, so if you're looking here, today's assignment is to make these parallel circuits, right? So not these, but these. And please note that the positive is up here on the battery, the negative is here, and the positive comes through and it connects to all three resistors at once. See, that's not the case here. The positive only connects to this one, then this other side connects to this guy, and then the other side connects to this guy, and so on. In parallel, this one right here, the positive connects to this one, and this one. Then on this side, all three connect to the negative. So that's very important. So if we're going to do this one and put an 8.2, a 6.8, and a 4.7, it would look something like this. Let's go over here. And we're in Tinkercad. And then make sure that you're not in 3D design. We're going to go to circuits right here. And then we're going to go create a new circuit. And if you want 12 volts, so first off we're going to need a breadboard, so let's just go ahead and do that. And then we're going to need 12 volts. If you note right here, we need a 12 volt power supply to make this happen correctly. So to do that, there is no 12 volts. You can take these batteries, I think, and keep adding them up. I think you can do 8 of these 1.5 volt batteries. You can take 8 of those. You could do this and add a 3 volt, or you could just do 4 3 volts if you want. So if you want to just do that, and that makes sense to you, go ahead and do this. I don't know why they're so big. They're really, really big for some reason. But the batteries are huge. So I'm going to do 3 of these, and that should do it as well. How big are these? Oh, those are, I don't know, 8 of these might work. I don't know. I'm going to delete this. Delete it. I'll just do this. These are 3 each. So those two together, as long as you're connecting, I think I messed up on this. So as long as you're connecting the negative to the positive, you're connecting them in series, which means you're adding more voltage. So that's what I'm doing, negative to positive. That will leave us with one negative down here. I can put the negative here in that negative row right here. So this will all be negative now, right? See how it all turns green? And this one will be positive. And we'll put this in this positive row right here. So this is all positive now. And if you want to make sure, just a quick double check to make sure you got the right voltage, we can get a voltmeter. It is in volt mode. We can take the positive and put it in the positive. We can take the negative and put it in the negative. And just push play. Where is it at? Start simulation right here. And it's 12 volts. So we're all good. Okay? So now I know my voltages are correct. Let's start and get those resistors. I believe there's 3 resistors, so 8.2, 6.8. Let's start with those. Let's go up here to the resistors. Let's grab them and put them out here. And there's different ways to do this. So I'm going to choose this method here, where I cross this. Remember, electricity does not travel from these bridge over to this bridge. So electricity travels all through here. Yes, it does, but it will not travel to this other side. That's why it's separate. Okay, so I'm doing that on purpose. And let's get this guy in a hole. There we go. That wasn't in the hole correctly. Space them out correctly. Let's get the correct resistances. I forgot what they were already. 8.2 and 6.8. So let's go 8.2, and that's kilo ohms. Good. 6.8, 6.8, and that's kilo ohms. That's good. And then lastly, 4.7 kilo ohms. There we go. So let me just double check that last one. Set right. There we go. Okay, 4.7. Yes, everything is good. Now, if we want to do the most simplest method, we would just take this. There's 2 ways to do this. So we can say here's the positive, and it goes to this guy. See, it connects down here. And it connects to this guy. Anywhere in this row doesn't matter. And then this one connects here, or anywhere. It doesn't really matter because these are all connected anyway. So all 3 have positive. Then all 3 need the negative over here on this side. And we're done, and that will work. How do I know it works? Well, let's put some voltmeters and find out. I have my voltmeter right here. It tells me how much voltage is here. So we're already good with that. Can I rotate this thing around? Yeah, I think it can. Look at that. That looks a little nicer and neater. I'll put it right here for neatness. I need some voltmeters or something, right? So let's see what I need. It tells you in the assignment. So right here it says repeat So we're doing this one here. Repeat step 1 for the circuit shown below. In this circuit, you will measure IT, the main current, the total current, that's what IT is, then the current for resistor 1, the current for resistor 2, and the current for resistor 3. They don't want any voltages. They want to know how much current travels here, here, and here for the resistor 1, 2, and 3, and they want to know the total current coming out of the battery. Alright, so let's do that. We're going to need 4 of these then for current. So this one will be the main one. We'll just go ahead and here's positive right here. That's perfect. So we'll delete this wire, and we're going to say you're still going to go here, but we're going to go here first to the positive, and then there we go. So it just goes in the machine and out, but make sure you select this and that this is in amperage mode, right? So it's reading amps or current. By the way, if you don't like how this travels behind there, you could totally just make this look much nicer if you wanted to. Like that, and you can adjust these and make it look really nice. Same thing here. If you really want to make this look a little bit more fancy, you can totally just kind of make this look a lot nicer and neater. That should give us the total current right here, 5.67 milliamps. That's the total current. All right. So now we need the current for all 3 of these. Let's start with one of them. So you got to think about this. The current travels out of the battery into this, and it tells us the current. It goes down this row, and then some goes here, some goes here, some goes here. I want to know how much is going to this guy here. So we need to intercept it. So we're going to say, okay, instead of you going here, you're going to go here. And remember, we're coming from the positive, so we got to go to the positive here. That's how that works. And let's see if I can adjust this a little bit. I'm going to need some more room, right? And then it was trying to go here, right? To there. So what it does is it still goes here, but it goes into this machine and out, and we got to make sure that this is in amperage mode. And it should read some current there. There we go. And it should be less than this because this is the total current for the whole thing. This is just the current going through this guy only. Now we need 2 more, and we'll just do that again. It's going to get a little crowded here, but that's fine. And we'll put one over here. So this one, we're going to, remember, it just goes from positive here to go to this guy. So we're just going to take him out. And we're going to say go ahead and go there, but you're going to go here first and then there. I'm trying to not cross wires. I don't like to cross wires. It looks a little ugly. So it goes in here and then comes out. And then lastly, this one here. We're going to go from here into the positive and then go back here. So it goes in here, then back out. Make sure this is in amperage mode. I think I didn't switch this one either. Amperage mode. There we go. And let's push play. There we go. So this plus this should equal 5.67. It looks like it about does. That looks about right. The voltage is no longer 12, it's a little lower, and that's just because a lot of the electricity is getting used, which drops the pressure in the batteries, and you lose a little bit of voltage. That's all no big deal. That's what happens when you use a battery, and you'll see that in class. What happens is you'll measure the voltage of something and go, oh, the voltage is this. And once you're using it, it kind of loses pressure, and then the voltage drops a little bit because it's being used. So it's neat that they actually show that even in this simulation. And that's it. This should be, that is what I want for a screenshot. All you have to do is take a screenshot. For me, I use a snipping tool. I type search and type in snipping tool, and I click new, and then I would just highlight over this, and then you can send this picture to me, just file, save as, and whatever you need to do. Otherwise, if you're on a Chromebook, just look up how to take a screenshot on a Chromebook and upload that. And this is it. Now, is there other ways to do this? For sure. I mean, as long as all the positive touches this, then the other side touches all the negative, we're good. And there's a bunch of ways to do that. For example, I'll show you on this side what I mean by that. So let's stop the simulation. You could have made it look more like the drawing, and I guess, and you could have said negative goes here, and then negative goes here, and negative goes here. So the electricity travels here and goes here, here, and here, and then crosses. It's still the same thing. They all, if you follow each one of these sides right here like that, it will lead back to the negative. This one will lead back to the negative. Yep, and this one will lead back to the negative. So when I push play, I get the same results. 11.8 on the voltage because of the voltage drop. All three currents will add up to that. It's still the same thing. As long as the path follows this path. In other words, does this one lead straight to the positive, and does this one lead straight to the positive, and does that one lead straight to the positive? Does this side lead all the way to the negative, and same here, and same here? Do they reach straight to the negative without passing through anything? Other than an amp meter or something like that, of course, because we're adding those amp meters on purpose. But as long as it's not passing through another resistor or something, and it just leads right back to negative, you're good as long as it follows this circuit. And I hope that helps you guys.